Hello, and welcome to Mr. Williams' Honors Pre-Calc class. We're going to go ahead and get started today with Chapter 1, Section 1, titled Points and Lines. Go ahead and copy the title. Right up here, you can see it. Section 1, Chapter 1, Points and Lines. I'll underline it for you. Okay. Objectives today. I would suggest copying these in your notes. You do get points for your notes. Objective 1, we're going to talk about the intersection of linear systems. In other words, where do two lines cross? So if I give you, one line in standard form, ax plus by equals c, where does it cross another line in standard form, ax plus by equals c? Objective number 2, we're going to talk about the lengths of line segments. How far is it from one point to another point on a given line segment? So if you have, this line segment, right here, could you tell me how far it is or how long it is? Well, if you know the 2 points that bound your line segment, one on, one end, the other one on the other end, you have a little handy-dandy formula here. It's called the distance formula, where d equals the square root of the difference of the two x coordinates squared plus the difference of the two y coordinates squared. Now, difference there just means minus. So that says d equals the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. And then our last objective is going to concern midpoints. To find the midpoint between two different points. And we usually say that the midpoint, capital M, and it doesn't have to be capital M, you can call it whatever you want, is the sum of the x coordinates cut in half, comma, the sum of the y coordinates cut in half. That's how you find midpoint. Okay, so let's get this stuff out of our way. If you need it, just rewind the video. And we're going to talk about the coordinate plane a little bit. Now, most of this should be review. I know it's been a while for a few of you, so I'm going to take it nice and slow and go over this stuff slowly. There's a little coordinate plane. I would just draw an x-axis and a y-axis if I were you guys. So your x-axis always goes left and right. Your y-axis goes up and down. We call this first section up here in the top right corner, that's called quadrant 1. And in quadrant 1, your ordered pairs are always both positive. In quadrant 2, we use Roman numerals. X is negative and Y is positive. In quadrant 3, they're both negative. Again, use your Roman numerals here. And in quadrant 4, working your way counterclockwise down here, x is positive, but y is negative. We've got a point here in the middle. This is called the origin. It's the ordered pair 0, 0. Hopefully this is just review. Most of us know that stuff. Okay, so let's get all this out of here. If you need that, just go back and copy it, rewind the video. And we got another definition. I got a definition here that I need to throw at you. We're going to define a line. Now, a line is a set of ordered pairs. Now, an ordered pair is just any combination of x and y. Positive, negative, rational, irrational, decimal fraction, could be anything. A set of ordered pairs or solution that makes a linear equation true. Now notice the root word of linear is line. So you need to be thinking linear equation means I'm talking about a line. So for instance, let's jump to our first example. Here it is. Example number 1. Now this says is the ordered pair 1, 5. Is it a solution of this line right here, 2x plus 3y equals 7. Now remember, that's just a line. It's in standard form. Standard form is ax plus by equals c. So how would you determine if the point 1, 5 is literally on that line? If you were to graph that line, I don't know what it looks like, it's just some random line here across the x and y axis. Would the point 1, 5 be on that line? Well, it's pretty simple. What you're going to do is you're going to take the x and substitute it in. So here's our equation. It says 2x plus 3y equals 7. Instead of x, you're going to replace it with the 1 up here. Okay, so let's do that. 2 times 1. And instead of y, you're going to replace it with 5. Well, that's pretty easy. Plus 3 times 5. And you're still just going to set that equal to 7, the constant, c. And just ask yourself, well, is that true? 2 times 1 is 2. 3 times 5 is 15. Does 2 plus 15 equal 7? Well, not in this universe. 17 plus equals 7, that's pretty stupid. Alright, so we would say the answer is no. The ordered pair 1, 5 is not a solution to that equation, and 1, 5 is not a point on the line. You with me? Rewind the video if you're not sure. Alright, I know it might take a few of you to get back into the groove. Okay, so let me just kind of tuck this example back up here in the corner, and I'm going to type out a definition and maybe the next example or two. Okay, so next definition I want to point out real quick is the definition of a linear equation. And we're going to talk about one in particular, and that's any equation of the form ax plus by equals c. Now, that's the standard form of a linear equation. There are a couple other forms, and you can jot these down if you want in your notes. One of them is y equals mx plus b. We've all seen that one. That's slope-intercept form. There's another one, point-slope form, y minus y1 equals m times the quantity x minus x1. That's called point-slope form, if you want to jot that down in your notes. Not going to use point-slope form a whole lot here in this first section, but definitely standard form and slope-intercept form. Now, back to standard form. In standard form, there's a couple conditions that I want you to take note of. That's that A and B, okay, A and B, I'm talking about this A right here and this B right here. A and B are both not 0. So, are both not 0, or both not 0. Let's say it like that. Are both not 0. In other words, one of them has to be there. Okay, one of them has to be there. And usually A is a positive number or it's 0. Okay, I don't like A to be negative. Some of the teachers will tell you different. I just think it looks a little tacky, and I know you all don't want to look tacky. A, B, and C are integers. Ooh boy, it's been a while since we talked about those. What are integers? Integers are not fractions and not decimals. They can be negative, that's fine, but they're not fractions and not decimals, and the greatest common factor of A, B, and C has to equal 1. So let's get that through our heads right now. A, B, and C have to be integers, which means, in other words, if you have A as like 2/7, you got a problem. You got to fix that. I'll show you how to fix that later. Okay, so let's get rid of what we just did. I'll tuck that in the corner. And we will jump to example number 2 here, if I can get it to blow up. There we go. I have a new app on my iPad that I'm just kind of playing around with, trying to figure out how it all works. Okay, so here's example number 2. Sketch the graph, oh boy, we're going to start graphing, of 4x minus 3y equals 12. Now, I highly recommend you guys use graph paper. In fact, when you turn in your homework, it has to be on graph paper. So, we're going to do this 2 ways. Method 1 is using what I call, in Algebra 1, I call it the cover-up method. It's to find the intercepts, to find the x-intercept and the y-intercept. Now, remember, Intercepts are where something crosses the x and the y-axis. The x-intercept will always be x comma 0, and the y-intercept will always be 0 comma y, whatever the y value is. Okay, so for instance, let's find the x-intercept first. Okay, to find the x-intercept, replace y, this y right here, replace him with 0. Okay, so I'm going to have 4x minus 3 times 0 equals 12. Well, 3 times 0, that's pretty silly. It's just 0. So 4x equals 12. Divide both sides by 4. X is 3. So the x-intercept is 3 comma 0. Similarly, you can find the y-intercept, but this time you're going to cover up who? If you want the y-intercept, you cover up the x value. Get rid of him. So in other words, just put a 0 in for x. I call it the cover-up method because it basically just kind of disappears. It goes away. So 4 times 0 minus 3 times y equals 12. 4 times 0 is a 0, so you're left with minus 3y equals 12. Now divide negative 3. Don't add 3. And you get y is negative 4. So now the y-intercept is 0, negative 4. Now that you have your two intercepts, draw a y-axis, draw an x-axis, and plot the points. 3 comma 0, 1, 2, 3 would be out here. And 0, negative 4 is down 4 right here. And there you go. There's your line. Now you did that using what I call the cover-up method. And essentially we just found the x-intercept and the y-intercept. Another method you can use, let me get rid of this stuff here. Same problem. Just kind of tuck that in the corner. The problem was 4x minus 3y. This is still the same example. This is method 2. And this might be one you're more familiar with. And that's to put this equation in slope-intercept form, which means to get y by itself. So pick up the 4x positive and drop it off on the other side. When you drop it off on the other side, it becomes negative. It's just like subtracting 4x to both sides. The 12 hasn't moved. It's still positive. And now divide by a negative 3 to get y by itself. Now notice, negative 4 over negative 3 is really positive 4/3. And 12 over negative 3 is negative 4. Now this is in slope-intercept form. It's supposed to be a 4/3 right there. And it's ready to graph. Let me see if I can... Oh, sorry. Screen's going crazy, isn't it? Here, I'll just graph it again. And you guys don't have to graph it again. Look at the line that you already graphed. It would start down 4. 1, 2, 3, 4. And on the graph you just did it start down 4? It did. And then it would go up 4. 1, 2, 3, 4. And right 3. 1, 2, 3. Boom. And there you go. There's your line. It should be the exact same line that we graphed the last time. Always start at what we call the y-intercept, which is this 4. You guys know this as y equals mx plus b. Does that look familiar? You start at b, and then m is your slope. And the slope either goes up and right or down and right, depending on if it's positive or negative. So, all right, nice job, guys. Very good. All right, let's get rid of this. Throw it down in the corner. Get out of here. We don't need you anymore. Pick up number 3. Let's bring it up here. All right. Well, now we're ready to move on. We've done problems with 1 line. Now we're going to do problems with 2 lines. I hope you're excited. Solve this system of equations. In other words, figure out where these 2 lines, ding, 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 where they cross, and tell me what that ordered pair is. Now, there's a couple different ways you could do this. The method you're probably most familiar with is called, say it, it's called elimination. Elimination means you need opposite coefficients on x or y. So I notice here that this says positive 6x. If he said negative 6x, what I could do is add the 2 equations together and cross out the x's. But right now he says negative or positive 3. Well, how do you turn positive 3 into negative 6? Well, you just multiply the whole thing by negative 2. But if you give him to one guy, you got to give some loving to the 2y, and you got to give a little love to the 4. So now that's minus 4y, and that's minus 8. The top equation, we haven't done anything to. You just copy the top equation. All right, now add your x's together. 6x plus negative 6x is 0x. Well, and 4y plus negative 4y is 0y, and so that's a 0. What? So the x's and the y's disappear. That's kind of funny. And notice 8 and minus 8, they also disappear. You get 0 is 0. Well, this is kind of a funny example. When this happens, you got to ask yourself, is this true or is it false? Well, this is true. This means that there are infinitely, and I want you to write this out, many solutions. Because actually, these two equations over here, boom, those actually represent the exact same line. They're just smack dab right on top of each other. That means the lines cross each other an infinite amount of times. That's why we say that there are an infinite number of solutions. Now there's 3 scenarios, let's get rid of this, that you will come across. First one, here's your x and y axis. You'll have lines that just cross at one single ordered pair. That's one solution, x and y. Next scenario, you might have this. You might have a line that does this, a line that does that. Those are parallel lines. What that means is that there's no solution. That's the no solution symbol with a circle with a line through it. That's if you end up with something stupid like 3 equals 5 or something. Remember we got 0 equals 0 last time? And then finally you might get something like what we just had, where there's only one line, and we can call that IMS. That's infinitely many solutions. Alright, it's the same line. Okay. Alright, so let's do a more fun example. One where we are actually going to get an ordered pair for a solution. This is example number 4. Solve the system of equations 2x plus 5y equals 10 and 3x plus 4y equals 12. Now remember, these are just 2 lines, and we're trying to figure out where those lines cross. What do you want to eliminate? Do you want to eliminate the x's or the y's? Well, we're going to have to multiply both equations this time. Let's go after the x's. If you want to go after the y's, be my guest. Now 2x and 3x. Now I know that both 2 and 3 both go into 6, but remember I need one to be positive and one to be negative. So what I'm going to do is I'm going to rewrite the top equation after multiplying it by 3. So 3 times 2x is 6x, 3 times 5y is 15y, and 3 times 10 is 30. Okay, now I'm going to take the bottom equation. I need it to be negative 6x, so I'm going to take the bottom equation times negative 2. Negative 2 times 3x is negative 6x. Negative 2 times 4y is negative 8y. And negative 2 times 12 is negative 24. Alright, cross out the x's. 15 plus negative 8 is 7y. 30 plus negative 24 is 6. Ooh, this one's pretty. You get y is 6/7 when you divide by 7. And that's fine. Just leave it like that. Don't you dare give me a decimal. Alright? Just leave it as 6/7. Alright, welcome to Honors Pre-Calc. Answers are nasty. Now, you're only halfway done. Alright, so take this 6/7, pick it up. And what you're going to do is plop it back into either the top equation or the bottom equation for the y value. So 2x plus 5, and then instead of y, you're going to put 6/7 and set that equal to 10. And now it's just a multi-step equation that needs to be solved. So let's see here. To multiply fractions, you multiply numerators. Remember, that's really 5 over 1, so 5 times 6 is 30. Leave 7, so 37. Now, what I would do here, and this is a good opportunity to show you guys how to kill fractions. If you don't want to work with those fractions, and I really don't want you running to the calculator yet, kill the fraction by multiplying everything here by 7. And I mean everything. So 7 times 2x is 14x. When you do 7 times the middle guy, the 7s, they're dead. Cross him out. Okay, and you're left with 7 times 37s is just 30. 30 survived that battle. Alright, because the 7s died. And 7 times 10 is 70. Alright, subtract the 30 from both sides. 70 minus 30 is 40. And now divide by 14. You get 40 14ths. Reduce, and you get 20 7s. So ding, 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 we do have one solution. That ordered pair is 20 7s, or 2 and 6 7s, and 6 7s. That's where those lines will cross if you were to graph them on a coordinate plane. Solving by graphing can be very disgusting. That's why elimination is a much, much better method. Okay, so I will move that to the corner. Move this to the corner. And I will bring your next example up. Here's number 5. Now this one I want you guys to do on your own. I want you to pause the video, and I want you to try this one on your own. See what you get. Just so you know, when you're done, the answer will be 5, -3. Okay? So, solve this one by elimination. I would multiply the top equation by -2 to eliminate the x's, but that's your call. So, however you want to do it. Okay, so here's our last example. It's got 2 parts, part A and B, number 6 for section 1. We haven't talked about distance formula or midpoint yet, and this is a big, big important part of section 1, so we need to hit it real quick. I'm giving you 2 ordered pairs, -3 11 and 4 -3, and I want you to find the length AB. In other words, how the length of line segment AB. So let's do that. Using our formula, look back at the beginning of your notes. Length AB, or the distance, we'll say, call it D, is equal to this formula. Remember, you take the x values, you subtract them, and then you square it. So the second x is 4 minus the first x, which is -3 squared, plus the second y, which is -3, minus the first y, which is 11, squared. Alright, and just figure out what that is. Now remember, 2 negatives make a positive. 7 squared is 49. I got that from 4 plus 3. -3 minus 11 is -14. When you square it, it's positive 196. Okay, so 49 plus 196, that's the square root of 245. Now you might remember from Algebra 2 that this radical can probably be broken down, and in fact it can. And if that's the case, you do need to do that. When you break down 245, you look for what I call twins, and what you're doing is you're trying to jailbreak them, bust them out of jail. 245 is really 5 times 49. 49 is really 7 times 7. Well, hey, there's your twins. So what you do, one twin busts out, 7. His buddy, he died. He's a goner. And 5 is left in jail. So you get 7 radical 5. Now this is the exact answer. In other words, it's 7 radical 5 units long, that line segment. And then squiggly, and squiggly is just my cute way of saying it's about 15.65 units. That's how long the line segment is. Now remember, this is approximate. Okay, that's not exact. That's the exact one, 7 radical 5, approximates 15.65. And I would expect that you would know the difference between the two. And then finally, let's find the midpoint between this point and this point. Midpoint, M, capital M, whatever you want to call it. What you do is, to find the middle of two things, you add them. So take your x's, -3 plus 4, cut them in half. And then take your y's, 11 plus -3, cut them in half. Well, negative 3 plus 4, that's just 1, so you get 1 over 2, or 1 half. And 11 plus negative 3, that's just 8. And 8 over 2 reduces to 4. So there you go. That's the midpoint between negative 3, 11, and 4, negative 3. Now, I do want you to put this with a picture to kind of visualize what all's going on here. So let me throw that up there in the corner. Get you a big old graph here so that you can see it. All right, plot point A. What was A? A was negative 3, 11. Well, I don't have 11 lines up, so I'm going to go by 2s on the way up. So 2, 2, 4. If you change your scale, you should always make that note. All right, don't assume that somebody knows what you're doing. Your horizontal axis is still going to go by 1s, though. All right, so negative 3 would be back 3, up 11, 2, 4, 6, 8, 10, 11, right about here. All right, that's point A. And then point B, what was that? It was 4, negative 3, so right 4 and down negative 3, which is actually only like down 1.5 since our scale is 2. Okay, play connect the dots. That's point B. And there you go. And another thing you can do is you could even plot the midpoint. The midpoint was a half and then up 4. So ding, 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 and looky there. Our line goes right through the midpoint. 1/2, 4. And that's actually halfway between A and B. And remember, what would this distance have been? How far is that distance? It was 7 radical 5 units, or about 15.65 units. Other ways you could have found that. We could use the Pythagorean theorem, but we'll just stick with that one. Okay, that's it for section 1. Thanks for joining me, and I look forward to working with you in section 2.